So there's often a raging debate between naturally aspirated engines and turbocharged engines. So people have very, very passionate feelings about each. And we're often asked, are turbo engines less reliable than naturally aspirated engines? So there's a few assumptions that people make, and a lot of it has actually been based on experience over the years. But things have significantly changed. We're just going to look in this video at some of the arguments about turbo cars and whether they are more or less reliable than their naturally aspirated counterparts. So why are we seeing so many turbocharged cars on the roads today? Well, the whole aim of car manufacturers now is to meet emission standards, so they need to make the engines ever more efficient. And a great way of doing that is to fit a turbocharger, which is effectively an air compressor, and it allows a relatively small engine to handle a lot more air coming in, which enables it to burn more fuel and make more power. So you're using the engine more effectively. It's making more power per litre capacity in the engine. So with naturally aspirated engines, you would typically expect manufacturers to produce up to around 100 brake horsepower per litre. That seemed to be the benchmark. A few manufacturers were able to exceed that. Most were slightly shy of those figures. But with a turbocharger, you don't have that limitation. So depending on the turbo, the setup of the engine, you can actually produce 200 horsepower per litre or more than that in some cases. So turbochargers really did make a massive difference in the power. Turbochargers were originally used on aircraft because it enabled them to fly higher, faster and longer and make more use of the fuel, because the air gets thinner the higher you get. And a turbocharger really helped the engines in these early aircraft to pull in enough air to keep burning, to produce sufficient power to enable them to keep that altitude and to maintain the speed that they were traveling at. And that technology has filtered down into cars. So are turbos less reliable than conventional naturally aspirated motors? Well, the original implementations of turbos, it's fair to say it was rather crude. The turbocharger added another level of complexity to the engine. So you're adding something that's potentially going to go wrong. So those early turbos, it was vital that you observed a proper warm up and cool down cycle. So even with modern turbos, you should give them a little bit of mechanical sympathy, just help to extend their life, bearing in mind this warming and cooling cycle. But it's also fair to say that the engine oils that we use have come on leaps and bounds. Synthetic oils specified now are far superior to the early oils that we used on those early turbocharged engines. So it would be quite common for those early turbos to cook the oil, to create this sludge inside the oil that caused lots of problems within the engine, as that affected the oil circulation and the overall viscosity of the oil itself. So naturally aspirated engines, they don't have that level of complexity, so their simplicity really makes them generally more reliable. But turbochargers have evolved a lot over the years, and because manufacturers know that this smaller capacity engine is handling more power, they beef up the components. You'll often get forged components on a turbocharged engine, whereas that manufacturer may opt to make a non-turbocharged variant of that engine, and they generally won't have the forged component. So the manufacturers have already done the calculations they need to maintain reliability in the engine by over-specifying the grades of metal that is used, the thickness of the block, for example, the types of pistons that are fitted. So manufacturers have already gone a long way to making these engines much stronger. Your typical diesel engine, for example, is turbocharged now, and it really does last a lot longer than those early petrol or gasoline powered engines ever would. But diesel engines are very, very different in the way they work. I've done other videos discussing diesels, so we're just going to focus on the argument of turbocharged engines versus naturally aspirated engines in this video. So further advancements that we've had in the world of turbos is really in the overall design. We have water-cooled turbos, which affected a lot of the temperature problems that were associated with those early turbos cooking the oil. So modern turbos have a reservoir system where they're able to store sufficient oil, so if you shut the engine off, they're able to provide a little more lubrication. It still makes sense to go through the warm up and warm down cycle just to ease the stress and strain on the turbo. And it's fair to say as well that a turbo engine generally runs hotter than a naturally aspirated engine. They're generally making more power per cc, so there's more heat going into the block and the metal component. But when manufacturers have looked at this, and they've developed a lot of expertise over the years, even manufacturers that have really pioneered the naturally aspirated engine, BMW switched, for example, from their silky smooth 6-cylinder inline engine that was naturally aspirated to 4-cylinder turbocharged engines, or 6-cylinder turbocharged engines. So the turbocharger has really extended the power, the economy and the efficiency of the engine. So manufacturers would be daft to ignore that, but they're also aware that it could make the engines less reliable. So are turbo engines less reliable than conventional naturally aspirated engines? Well, it's like comparing oranges and apples. They're different things completely, and it depends on the manufacturer. I can rattle off the name of a lot of naturally aspirated engines that have been notoriously unreliable. I can also rattle off the name of a lot of turbocharged engines that have been notoriously unreliable. So even brands like Honda, that have a supreme reputation for reliability, had issues when they introduced a turbocharged engine. I think it was their 1.5 turbo engine that was suffering from oil dilution, so that was a bit of a design fault in the engine, so that led to premature failure of these engines. That adds weight to the argument of people that say that turbocharged engines are less reliable, but it really does depend on the manufacturer. And if the engine has been evolved over a period of time, generally speaking, those newer generation of engines are much more reliable and better designed than those early engines, because manufacturers learn from their mistakes. They want to have a reputation for producing reliable, trustworthy engines. But one of the critical things really is you as the driver and the owner of the car. You're responsible for the maintenance of the car, and the maintenance requirements of a turbo is quite different to a naturally aspirated engine. So if you like to change the oil once every 5 years and you don't really want to check the dipstick, then perhaps a large capacity V8 engine is the one you should go for. If you're happy to check the oil levels, check the oil quality and perform the regular servicing that's required, then a turbocharged engine gives you really the best performance, the best economy and the best terms of having a long-term reliable engine. But you really can't neglect the turbo. It's a bit of a diva, it's a bit of a Goldilocks. It's very fussy over the type of fluid you put into it, from coolant and also from the engine oils that are specified. And manufacturers have gone to long lengths to specify very specific formulations of additive packs that go into those components to reinforce the strength and the long-term reliability of their turbocharged engines. So it would be foolish to ignore that. It would be foolish to neglect the car. If you look after your car, it's going to look after you. So I hope this has just given you a bit of fresh ammunition in this debate as to whether turbocharged engines are more reliable than naturally aspirated ones. And for me, the key takeaway really is up to the owner to maintain them, and turbocharged engines generally require more maintenance and they're a little more fussy, but as long as you meet those requirements, there is no reason why a modern turbocharged engine can't outlast a naturally aspirated engine. Thank you for watching. Please boot that like button, that really does help us to get out there, and I've lined this video up for you that you should find really interesting. Thanks for watching and see you in this next video. If you haven't subscribed, please do so. We'd love you to stay tuned.